video is over Chapter 6, Exponents. So our first exponent rule is when you are adding and subtracting polynomials. So for example, when we are adding and subtracting polynomials, they must have the same base and exponent. And if they do, we do not change the exponent, but we are going to combine the like terms. So the way we know we are going to use this rule is when we read this says 5x squared minus 8x cubed plus 7x squared plus 10x cubed. We are adding and subtracting. So we can combine the 5x squared with the 7x squared because they both have x's, so they have the same base. And remember, a base is what has an exponent on the top right-hand corner. And they have the same exponent. So we are allowed to combine those, and we're going to add them because they're both positive. And we're going to take the coefficient, the number in front of the x, and add them, and we get 12x squared. Then we can combine the negative 8x cubed with the positive 10x cubed, because again they have the same base and they have the same exponent. This one's positive, this one's negative, so we subtract them, take the sign of the bigger number, and that becomes positive 2x cubed. So if we were to write this in standard form, the one with the higher exponent would go first. So I could rewrite this as 2x cubed plus 12x squared. Okay. Our next rule is when multiplying polynomials. So for example, when we're multiplying polynomials, they must have the same base. And when they do, we're going to add the exponent. So this negative 2 here and this positive 4 here, those are not bases. They do not have an exponent. They are coefficients. They're the numbers being multiplied by the variables. So we are going to multiply these just like normal. So negative 2 times 4 is negative 8. And then this has the same base as that. So the rule is we are going to add the exponents. So 3 plus 2 is 5. And if it's positive when you add the exponents, then the variable stays in the numerator on the top. Okay, so these have the same bases. They both have y's. So 3 plus negative 6 is negative 3. Since it is negative, we are going to move it to the denominator. And then it gets rid of the negative by moving it to the denominator, as we proved in class. Okay. Our next rule is if we have an exponent outside parentheses like this. So we have a negative 2 on the outside here. So we are going to distribute this negative 2 to everything, to the negative 3, to the a squared, to the b, and to the c, and also c to the negative 3. And the rule is if there's exponents, you're going to multiply the exponents. So first of all, we have negative 3 to the negative second power. So I'm going to write that out so we can see it. And then we have a, and what we're going to do is multiply the exponents. So that's 2 times negative 2 is negative 4. And then b, every variable has an exponent, so there's a 1 right there. So 1 times negative 2 is -2. And then -3 times -2 is 6. So, -3 to the -2nd power, remember a negative exponent moves it to the denominator, so we're going to do -3 squared just like normal. -3 times -3, which is 9, but because it has this negative there, we're going to move it to the denominator. Then a has a negative exponent, so we're going to move that to the denominator and get rid of the negative. And then b has a negative exponent, so we're going to move that to the denominator. But the c to the 6th power does not have a negative exponent here, so it's going to stay in the numerator on the top. And that is our final answer. Okay, our next rule is for dividing polynomials. So for example, to divide polynomials, they must have the same base. If they do, we're going to subtract the top exponent minus the bottom exponent, so numerator minus denominator. If you get a negative, it goes to the denominator. If you get a positive, it goes on top. So the 6 and the 15 are not exponents. So these rules are not for the 6 and the 15. We are going to simplify that just like normal. So 3 can divide into both of them. So it equals 2/5. And then this has the same base as this one, so the rule is we're going to subtract. We're going to take the 4 minus 2. And because it is positive, the a to the 2nd power is going to go on in the numerator. Then here we have the same basis, so we're going to do 3 minus 3, and that is 0. They are going to cancel out and make one whole. In other words, anything to the 0 power is 1. So those we can just ignore, because if we put a 1 here, 2 times 1 is just 2, so we don't need it. Okay, then for the y's, we have 5 minus 8, which is -3, so since it's negative, it's going to go to the denominator, the y cubed. And that is our final answer. Okay, let's go ahead and take a look at another one like that. Let's take a look at this one. So same thing, the -4 and the 8 are just coefficients, so we're going to simplify them just like normal. So negative divided by a positive is a negative, and 4/8 can be divided both by 4. And then we're going to, these have the same basis, so we're going to take the top minus the bottom, the numerator minus the denominator. And it's negative, so we're going to have x to the 5th in the denominator. And then here we have, every variable has an exponent, so there's a 1. So 1 minus -4 is 5, because these make a positive. So because it's positive, it will go in the numerator. We could also write this answer, because 1 times anything is itself, we could also write it as y to the 5th over 2x to the 5th. And this negative can go out in the front or out on the side here. Let's do a couple more examples with negative exponents. So if we have 3 to the -2nd power, remember a negative exponent, this says 3 to the 2nd power, which is 9, and the negative is going to move it to the denominator. Remember we proved For example, like 3 to the third power, that's 27. 3 squared, that's 9. 3 to the first, that's 3. Anything to the 0 power we proved was 1. So there's a pattern here. We are dividing by the base, by 3, every single time. So if we do that, 1 divided by 3 would get us what 3 to the negative 1 power is, which is 1/3. And then if we continue 3 to the negative 2nd power, if we do 1/3 divided by 3, and we flip it, we get 1/3 times 1/3 is 1/9. So when something has a negative exponent, it doesn't mean the answer is negative. We're going to do 3 squared just like normal. It's 9, but it moves to the denominator. So 1/9. Okay. So we have an exponent on the outside. So this is our rule. We're going to distribute the exponent to everything inside. So we're going to distribute it to the 2. So that's 2 to the negative 3rd power and 3 to the negative 3rd power. So since it has a negative exponent, we're going to do it just like normal. 2 to the 3rd is 8, but that negative means it's going to move to the denominator. And this is 3 to the 3rd power, which is 27, but that negative means it's going to move to the, since it's already in the denominator, we're going to bring it up. And our answer is 27/8. Okay, let's take a look at another example here. So we're taking 2x to the 5th minus 8x plus 7, and we're taking this polynomial and subtracting this polynomial from it. So since we are subtracting, we need to use our rules for adding and subtracting. So when we have a subtraction in front of a parenthesis, a trick we could do is, this is saying the opposite. We're going to take this and subtract all of this. So if we distribute this negative through, it makes everything in the parentheses opposite signs. So the opposite of 3x to the 5th is negative 3x to the 5th. The opposite of negative 2x is positive 2x. The opposite of 4 is negative 4. Then I'm going to bring down this polynomial, and there's nothing in front to distribute. And now to combine, to go further, they must have the same base and exponent. And if they do, do not change the exponent. So we could put the 2x to the 5th, and we can combine it with the negative 3x to the 5th. And they are different. One is positive, one's negative. This one's bigger, so we get negative 1, or just negative x to the 5th. And then we can combine the negative 8x with the positive 2x. They are different. This one's negative, this one's positive, so we subtract them. And then same thing, these are different, so we subtract, so we get positive 3. And we cannot go any further because these have the same base, they're both x, but they don't have the same exponent. This one's a 5, and this one's a 1. Okay, if we take a look at this example here, if I read this, this says 2x minus 3, the quantity of 2x minus 3, times the 4x plus 5. So since we are multiplying, we need to use our rule for multiplying. So if they have the same base, add the exponents. Okay, so we have 2x times 4x, so I'm going to ignore this one. I got to multiply both of those to both of those. That's what it's asking us. So I'm going to FOIL here. So 2x times 4x. So 2 times 4 is 8. And the rule is if they have the same base, add the exponents. So 1 plus 1 is 2, so it's 8x squared. Then 2x has to be multiplied to the 5. So 2 times 5, that's positive 10. And then they don't have any bases to add the exponents, you just have this just x right here. Okay, then I need to distribute the negative 3, so negative 3 times 4x, so negative 3 times 4 is negative 12, and then the x there's only an x there. And then we have negative 3 times 5, which is negative 15. Okay, now when I look at what we have left, this says 8x squared plus 10x minus 12x minus 15. So now this rule is going to go away, and now we are using the rule for adding and subtracting polynomials. So to go further, they have to have the same base and exponent. So this one has no other x squareds to combine with, so I'm just going to bring it down. But right here we have a positive 10x and a negative 12x. They have the same base, and they both have a 1 as an exponent. So we are allowed to combine these right here, and they're different, so we subtract, and we get negative 2x. And then the negative 15, the constant, we just bring down. And that is our final answer. We cannot go any further. Okay, with our next example here, we have to take the quantity of x minus 5 and we have to square it. So this is different than if we had this example. If we have this example, there's just a monomial inside the parentheses. So we would just do 5 squared, and then 3 times 2 is 6. Or another way to look at it is this is saying 5x cubed times 5x cubed. So 5 times 5 is 25, 3 plus 3 is 6. However, it is incorrect. We cannot do this. We cannot do x to the second power is x squared, and negative 5 to the second power is positive 25. That is incorrect. So let me show you why. If we do the same thing I did here and rewrite it twice, if I do that here, x minus 5 times x minus 5, and we go ahead and multiply that, let's see what happens here. So we have x times x, so we add the exponents and get x squared, and then x times negative 5, there's a 1 here, so 1 times negative 5 is negative 5x, and then negative 5 times x, that's also negative 5x, and then negative 5 times negative 5 is positive 25. And then we can combine our like terms here. That makes negative 10x. Bring down the 25, bring down the x squared, and as you could see, we will not get the right answer by distributing the exponent here, because then we would only get x squared plus 25. We would leave out the negative 10x, which is part of our answer here. So, to compare these here, this one, we are allowed to distribute the exponent, but here, because there are two separate terms, this is a binomial, we cannot distribute the exponent.